Sea turtle, sometimes called marine turtles, are reptiles of the order Testudines and of the suborder Cryptodira. The 7 existing species of sea turtles are the green sea turtle, loggerhead sea turtle, Kemp's ridley sea turtle, olive ridley sea turtle, hawksbill sea turtle, flatback sea turtle, and leatherback sea turtle. All 6 of the sea turtle species present in U.S. waters, loggerhead, green sea turtle, hawksbill, Kemp's ridley, olive ridley, and leatherback, are listed as endangered and/or threatened under the Endangered Species Act. The 7th sea turtle species is the flatback, which exists in the waters of Australia, Papua New Guinea and Indonesia. Sea turtles can be separated into the categories of hard-shelled, cheloniid, and leathery-shelled, dermochelyid. There is only one dermochelyid species, which is the leatherback sea turtle. For each of the 7 types of sea turtles, females and males are the same size. There is no sexual dimorphism. In general, sea turtles have a more fusiform body plan than the terrestrial or freshwater counterparts. This tapering at both ends reduces volume and means that sea turtles cannot retract their head and limbs into their shells for protection, unlike many other turtles and tortoises. However, the streamlined body plan reduces friction and drag in the water and allows sea turtles to swim more easily and swiftly. The leatherback sea turtle is the largest sea turtle, measuring 2-3 meters, 6-9 feet, in length, 1-1.5 meters, 3-5 feet, in width, and weighing up to 700 kilograms, 1,500 pounds. Other sea turtle species are smaller, being mostly 60-120 centimeters, 2-4 feet, long and proportionally narrower. The skulls of sea turtles have cheek regions that are enclosed in bone. Although this condition appears to resemble that found in the earliest known fossil reptiles, anapsids, it is possible it is a more recently evolved trait in sea turtles, placing them outside the anapsids. Sea turtles can be found in all oceans except for the polar regions. The flatback sea turtle is found solely on the northern coast of Australia. The Kemp's ridley sea turtle is found solely in the Gulf of Mexico and along the east coast of the United States. Sea turtles are generally found in the waters over continental shelves. During the first 3 to 5 years of life, sea turtles spend most of their time in the pelagic zone floating in seaweed mats. Green sea turtles in particular are often found in sargassum mats, in which they find food, shelter and water. Once the sea turtle has reached adulthood, it moves closer to the shore. Females will come ashore to lay their eggs on sandy beaches during the nesting season. Sea turtles migrate to reach their spawning beaches, which are limited in numbers. Living in the ocean therefore means they usually migrate over large distances. All sea turtles have large body sizes, which is helpful for moving large distances. Large body sizes also offer good protection against the large predators, notably sharks, found in the ocean. As a result of the COVID-19 virus, human activity on all beaches has virtually ceased, resulting in an increase in sea turtle nesting. In Thailand, the highest number of nests in the last 20 years have been found during 2020. Turtles are thriving across the United States as well, as there is less noise and pollution. Below the surface, the sensory cues available for navigation change dramatically. Light availability decreases quickly with depth, and is refracted by the movement of water when present. Celestial cues are often obscured, and ocean currents cause continuous drift. Most sea turtle species migrate over significant distances to nesting or foraging grounds, some even crossing entire ocean basins. Passive drifting within major current systems, such as those in the North Atlantic Gyre, can result in ejection well outside of the temperature tolerance range of a given species, causing heat stress, hypothermia, or death. In order to reliably navigate within strong gyre currents in the open ocean, migrating sea turtles possess both a bicoordinate magnetic map and magnetic compass sense, using a form of navigation termed magnetoreception. Specific migratory routes have been shown to vary between individuals, making the possession of both a magnetic map and compass sense advantageous for sea turtles. A bicoordinate magnetic map gives sea turtles the ability to determine their position relative to a goal with both latitudinal and longitudinal information, and requires the detection and interpretation of more than one magnetic parameter going in opposite directions to generate, such as magnetic field intensity and inclination angle. A magnetic compass sense allows sea turtles to determine and maintain a specific magnetic heading or orientation. These magnetic senses are thought to be inherited, as hatchling sea turtles swim in directions that would keep them on course when exposed to the magnetic field signatures of various locations along their specious migratory routes. Natal homing behavior is well described in sea turtles, and genetic testing of turtle populations at different nesting sites has shown that magnetic field is a more reliable indicator of genetic similarity than physical distance between sites. Additionally, nesting sites have been recorded to drift, along with isoline shifts in the magnetic field. Magnetoreception is thought to be the primary navigation tool used by nesting sea turtles in returning to natal beaches. There are three major theories explaining natal site learning: inherited magnetic information, socially facilitated migration, and geomagnetic imprinting.